Welcome.
Hey everyone. Yeah, thank you. Thank you, Stefan, for organizing this meetup and inviting me there. Today we'll talk about animating 3D characters with Bevy. I didn't incorporate the animation graph yet, but I tried and there are some bugs, but it will be planned for 0.14. But I will talk about it. So my name is Julian. I'm a software developer and I also enjoy game dev. 5 months ago, I started a new project, 3D project with a 3D character, a samurai slashing bad guys. So I needed some animations, but I don't have animation skills yet. I'm still learning and I'm still modelizing my character. So I decided to go with some dummy characters. This one, saying hi, is coming from Mixamo. That I use for prototyping my game. You have high definition characters, a lot of different characters, and high definition animations. I really recommend this website if you want to have some animations. You can download the character and the animations, and you will get an FBX file. So you need to generate a GLTF file, which is the format supported by Bevy. I will not dive too much into this process. There is a video smooth animations with Bevy I made if you're interested. But quickly, what you do is just you import the armature, which is the skeleton and the different bones from the character. Also the animation from Mixamo to Blender, so an FBX file that you import. Then you will edit the animations, maybe the keyframes, disable some of them, enable some of them, and then you will export a GLTF file. So this file is supported by Bevy and also Blender, and you can export a binary format. But if you're curious and you need to inspect the file, you can check the human readable format, and you will see that you have everything about your 3D model. The keyframes, the animations in our case, the vertex skinning, so the bones, the weight of the bones will influence the vertex, and also the meshes of your character, and you will have much more like materials, texture. You can learn about GLTF with this repository coming from Kronos Group. So we'll directly dive into Bevy Animation Crate. We talk about the low-level API, and I will make parallels with Blender so you can understand visually how it works, not only code, but also some visuals. So the first animation I need to talk about is keyframes, because we can't talk about animations without any keyframe. So this animation offered 3 different variants. The last one, wait, I will not talk about it because I didn't try, but it's for morph targets. So for example, for facial expressions and stuff like this. But I will only focus on rotation, translation, and scale. Those 3 variants will have a bunch of keyframes that you can put. For example, you want to rotate the head bone of your character. In that case, we just provide a bunch of quaternions. Quaternions are used for rotation. And each keyframe will hold the value for the specified rotation you want. So let's say, for example, you want to rotate by 30 degrees, you can have different rotations to achieve it. Then those keyframes will be used in a variable curve. In Bevy, we talk about variable curve, but in Blender, we have F curves. Those are different naming conventions, but it's quite the same. So the variable curve will be a way to define how you play the different keyframes, how you play the animation. So we need timestamps. Each keyframe will be spread over a specific timestamp. So it will be frame dependent. Most of the time we'll have 1 keyframe per frame. And this keyframe will add some information and it will interpolate the two keyframes. So for example, you have linear, step, and cubic spline interpolation methods that you can use to interpolate from one keyframe to another. So we can create all the different steps between 2 keyframes. It will just avoid to have issues like defining all the different keyframes. You can just have a gap between them, and the engine like Blender or Bevy will just provide all the different parts. This is the view from Blender. So at the very top, you see the character that is redrawing the sword, and you can see the skeleton with the X-ray view. And then you have this graph editor where you can see the different curves that are being used, and the different keyframes, those dots that you see. And you will play the animation, and over time you play the different keyframes. And you have for each keyframe an interpolation method that is applied. And on the right, you can see that we have a bunch of bones that are defined for the armature. Each bone in Bevy will be considered as a component where you can just add different properties. Like you want to rotate this, I don't know, the head, for example, or the hips. When you run, you can translate and you can scale. Then once you have the curve, you need an animation clip that will wrap all this information and also describe which components will be animated. So as you can see, the first information is the curves, and then you have the path. Each entity path is a path to your bone, for example, depending on what you animate, but in case of character, you have bones. And it will have a specific duration. Then you have the animation transition. This one is used when you want to smoothly transition from one animation to another, and we just decrease the current weight of this animation, and it will be faded out to be replaced by a new animation. And now we will start to talk about the high-level API. Once you exported the GLTF file, that's what you will use, the animation player. So you can control the different animation clips in your game. You can, for example, repeat an animation, you can pause, resume, and you can start or play with transition, and you have many more methods. So now let's use this high-level API and provide some example about playing animations. This is what I use for my character. So I will have a demonstration. It would be maybe a bit better to explain how it works, but we'll dive into the code first. So I use enumerations because it's quite difficult to know which animation you are playing if you just use indexes coming from the GLTF file. So I decided to use a summary animation with different variants. Each variant will be a U8 representation. So for example, idle will be 0, withdrawing 1, slashing 2, and so on. So it will be very expressive, easier to read in the code than indexes, but still you need those indexes to load the specific animation. So I derived an emitter, which provide a way to just iterate over the variants, and for each variant you get the U8 representation, and then you can use it to load the specific animation, and then you will collect them, you will get a vector of animation clips, which are handles, and you will insert the resources. As a quick note, I use enumerations coming from the leaf-wing input manager. So you have this action light trait. You can use it to just bind all the different inputs to a specific variant of an enumeration. So here I have a samurai action. I have the attacking variant, which will be binded to the mouse button left in case of a mouse keyboard setup, and to the west button of a gamepad button. So for the same variant, you have two different bindings in this case, which is very handy and very expressive too. Very quickly, I have a graph representation. This is not the underlying implementation of my game, but just a way to have a mental model of how it works. So if we start with the default animation, the hidden animation, which is a node, I will transition to withdrawing. To transition, I need to have a specific condition. The mod needs to be passive because you can't withdraw a sword if you're already fighting. It means you already have your sword. So from idle to withdrawing, you need to be in a passive mode. You need to click on mouse one, and you will mutate the state to an attack mode. And the same will be applied for slashing, but the slashing animation has the specificity of being repeated if you click on mouse one. But you can also have external events. I didn't implement any of them, but that's just some ideas. For example, you could have damages in case you want to automate everything. For example, let's say you have an enemy that is starting to attack you. You are in idle mode. Then maybe you can automatically start to withdraw the sword and start to slash the enemies. Or maybe you don't have any user input, and for 2 minutes you decide to just shade the sword, and then you will go back to the idle mode automatically. So this is what I would like to have a state machine at the end. It's not yet implemented. And then we need to play the animations. How do we do this? We have systems in Bevy, and there is the system specific for animations, my samurai animations in my case. And I decided to use a local variable using my enumeration samurai animation to track the current animation in the system. This is just specific to the system, so it will not be used outside. And it will be helpful to just decide which animation I need to play. And then I also have the player mode passive or armed that will help me to just decide if I should withdraw or slash the enemies. Here's a very simple example. You can repeat an animation. In my case, it was for the idle animation. So you can see that I use the repeat function, but you also add this play with transition. The reason is if I'm running or if I'm attacking and I want to go back to the idle mode, then I want to smoothly transition between the animations. So this function is offering this possibility. Then a more complex example. There I have an attack that is being listened for the player input. And I will decide based on the player mode if I should slash or withdraw. In case, I have 3 cases: withdrawing, slashing, simple slash, or slashing multiple times. You know, when you are in a game and you have enemies, you would just spam the attack button and you try to just kill all the enemies. But you don't necessarily want to play each time the same animation. You just want to let it finish enough to get the feedback for the user. If you spam the attack, you will get the same keyframe be played over and over, and it will be very hard to see what's going on. So I prevented the spam attack by checking the seek time. You have this function that will allow you to just check where you are in the animation. In my case, 0.7, yes, was working correctly. So you go from 0 to the duration of the animation clip. So if I'm more than 0.7, I will use this function start with transition. This one will allow me to just replay the same animation, but I just transition. For example, I slash, and then at the middle of the attack, I stop it, and I will slash again. It will help me to just have a very good feedback for the user when I attack. But in the case I'm below the 0.7 information, so the condition is below 0.7, I will just play with transition, but because this function doesn't play the same animation if it's already playing, it will just prevent, to replay the animation, and we let it finish. And in case I'm withdrawing the sword, this function will also take it into consideration, because I just need to play it from the first frame to the last frame. This is demo time now. I have just a simple game with an isometric view. This is what I'm working on actively. I have an isometric view and isometric movements for my character. There is the run animation. And if I stop, it will just transition to the dead state. Then I can also use my gamepad there. I can do the same, but I also have some implementation to improve, because as you can see, if if I just move just quickly, it will not transition correctly. I need to fix this. And I can also withdraw the sword and start to attack. If we just use the perspective camera, it will be just easier to see. So as you can see, I can just spam the button, but the animation will not be spamming. Still, I can play multiple times the same animation. And I can just shield the sword. And I go back to the idle mode. This is using the current implementation 0.13, but as you can see, if I run and at the same time I decide to attack, this is very weird, right? This is because I don't have a way to play 2 animations at the same time, just trying to transition from one animation to the other one and never playing the animations together. I need to run and attack at the same time. So for this, I will need the animation graph, which will be in the 0.14 version of Bevy. It will have a root node, and each node could be something that you blend. You will be able to define how much you want to blend, and you can create this blend mode. This is what I will need, and I will have the attack animation and run animation blended together. But that's not really enough, because if you want to really have a smooth animation, we need to add the upper body playing the attack animation and the bottom body running. It will be just a bit better. And I don't think Bevy supports for the moment layer mask. This is what Unity does, for example. I don't know for other engines. And this is my experiment with the animation graph. I was experimenting, trying to add it for my game for this talk, but it didn't work. And I have a bug. I reported a bug to the repository. So currently we have one animation that is not transitioned correctly. If I play multiple times the slash animation, we see that we are decreasing the weight, but it doesn't fade out correctly. I don't know. It just doesn't play the animation. So we still need a fix. Future plans, what I envision, I already talked about it just a bit, but an animation state machine representation, which will be helpful to debug, to have something a bit more complex where I have nodes and transitions with the edges. A layer mask, maybe I can try to implement it, or maybe it will be planned for Bevy. And an in-game animation inspector. Blender is enough for that, but when you have hitboxes and outboxes, then what you want to do is just to pause the animation and see how the animation will affect the hitboxes and outboxes to just debug this. And this is what I will try to implement next. So that's all for this talk. Thank you for listening. And now it's question time.
Hey, Julian, thanks so much. Amazing talk. I think I confused the animation graph that is not out yet with what we talked about and what you use already in there. Sorry for that confusion.
Yeah, no problem. I was trying to implement it, to be honest, but because of this bug, it prevented me to just continue. So I have the implementation, but it doesn't work yet.
Yeah. Okay, we have a few questions. Let's look into that. How does the blending between two animations work? Is it something that I define in the GLTF file?
Well, it depends where you define the blending, because you can do it, I think, directly with Blender. But no, this is Bevy who is doing the blending. And currently just fading out the current animation to the next one. I think there is some blending at some point, but I didn't try to manipulate directly the low-level API. So everything you saw there is directly in the high-level API.
Okay. Yeah, the classic, what kind of game is it that you're working on?
Well, it will be a voxel game, but for the moment, I have some kind of placeholder for the samurai and stuff like that, so I can try to implement. But it's a voxel game with a samurai, a bit like Hades. You get a random room and you slash enemies and bosses.
Amazing. So, any time frame for that one?
What? No, I don't have any. No.
When it's done. Okay.
It will be a long run.
Yeah, I guess this was answered before. The blending between animations is not released yet, right? Or is blending something that works? It's just not the graph that doesn't work yet.
Yeah, the graph will offer a way to configure the blending in programmatically or directly with a specific file, but it's not yet implemented. But you have some blending done directly in Blender currently, but I don't have all the technical details.
Okay, and you mentioned a separate file format for the animation graph. Is that something so you can basically put these different weights and everything into a run or some file like that?
A run file where you can define all the specifics for blending and create your own nodes.
Yeah. So this next one hooks into a classic issue with such a everything ECS style application, I would say it is using a local for the animation playing. It could be manipulated elsewhere, correct? And therefore getting out of sync. I guess that's not just for this specific use case a problem, but if you use a local for something like that, then you could still have other systems picking it up somewhere else, triggering an animation, and your local wouldn't be in sync anymore, right?
Yeah, the way I understood local is just specific to one system, but maybe I'm wrong. I don't know.
Yeah, exactly.
For me, just this system that will have access to the local variable, and it will not
Yeah.
be, yeah, manipulating.
Yeah, but I guess the point is that you could have this system thinking some specific animation state is running because that's what the local says, but some other system could just have hooked into the animation player and just triggered whatever.
Oh yeah, yeah,
Right.
definitely.
Yeah.
Yeah, if you have multiple systems for the same animation.
Yeah. Okay. I see using hard-coded time offsets for transitions like the greater 0.7. Is that something that can be picked up from the GLTF, like markers?
Honestly, I don't know. For me, it's just coming from. So you have the current implementation low level API is just playing over time based on the animation clip duration. So you can change the duration, but I don't think you can have a marker or something like this. I don't. Well, I don't see the link between two. This is just Bevy playing the animation clip and the duration decreasing or changing based on your of what you do with the API.
Yeah, but I guess you could have animations that transitions. I mean, that are depending on what happens in the animation, right? And then you would have the times to be synchronized with what is defined in the animation in the Blender file.
Yeah, you could certainly define something like this, but I don't know for GLTF. But definitely, yeah, could be achieved. That's what I would like to do with the state state machine.
Okay. Last question. How is it to work with a part of Bevy that is such a moving target and actively worked on? Are you permanently on master?
Well,
and I
no.
personally would add, how do you start with animations in your project? Like, how is this the first thing?
Yeah, for me, animations are everything in the game. So if you have animation, you get the feedback. If you get the feedback, you can play test very early your game. And I was able, thanks to the Leafwing Input Manager too, to test it on Steam Deck with the gamepad controller and mouse keyboard. But how do I keep up with the Bevy? I don't. That's why I'm still in the official version, not the dev version. But when I tried, the issue is you need to also update your plugins, and it's very difficult because you need to, just use a specific version of Bevy and update the version in the plugins and update the code just to try it. So more plugins you have, and most difficulties you will find to just try a specific version. So I don't try it too hard. I tried for the animation graph because I needed to just experiment. But yeah, definitely, I don't try to keep up with all the updates. I just wait.
Yeah, I guess that's a good point, especially the what you make with the plugins. That can be a nightmare, especially when you then want to go on master and some stuff is not up to date with some recent change yet.
Yeah.
Yep, Julian, thank you so much.
Yeah, thank you.
Let's see if there's more questions popping up throughout the event. Maybe we can have a little panel discussion at the end again. I'm definitely looking forward to see you around later again. And
Yeah, okay.
I hope you have good. You will make good progress on the project. I'm keen to see what's happening there. So keep us posted.
Yeah, I do live streams, so definitely at least one per week.
Yeah.
You'd show the game.
Cool, Julian. Thank you.